All right, good morning, everyone. I once again apologize for you guys kind of getting the short end of the stick here. I'm at home doing my interview. Hopefully, it's going well. Today, you are going to have the wonderful opportunity to do sort of two sets of notes at once. And so we're going to do both the lunar properties as well as moon phases today. So I've shortened down the moon properties notes to the lowest logical level. Ignore this up here. Sorry, I just realized that we already did that. So this was a page I forgot to update from last year. So don't worry about that. We covered that last week. So you should be on your moon property notes. We're going to get a bunch of new words, but they're all pretty straightforward. How did the lunar mare form? And one of your guiding questions over here could be, how did the moon form? There's a few theories. There's one very, very leading theory. So if you want to take a minute to write those down. While you're copying this down into your notes packet, please remember that your keynotes are due at 7:30 tomorrow morning. You're welcome to email me any questions that you might have. I should be here starting fifth period today if you want to come in, if you have lunch, if that works out for you, or if you want to swing by after school. That way you feel like you know what you're doing. I would hate for you to be at home working on your keynote and not feel like you're prepared to turn that in tomorrow. It is a big grade, and I look forward to seeing them. All right, here we go. So the picture of the day is kind of cool. It's just what all the other, what if the other planets were as close to us as the moon? So if you were able to put all the planets at the same distance as us as the moon is what they would look like. And I just thought that was something to make you go, huh. Okay, so if you think back to weather, this kind of feels a little choppy because I got rid of some other slides that just had some fluff on them. If you think back to weather, you might remember the term albedo. So albedo is the percentage of light that gets reflected off of different surfaces. So if you take a look at this, it says that the percentage of incoming sunlight that is the surface reflects is very small. It's only 7%. So the moon might look really bright to us, but it's only reflecting 7% of the light that's hitting it. On average, we have an albedo of 31%, and that, obviously is because we have water and ice on our planet. And so the moon looks bright to us, but it's really not that bright. Some things you may have learned about in world history or U.S. history was the Cold War. We lost the original space race. The Soviet Union made it to space first. That is Yuri Gagarin, the first person in space. This is Sputnik, and this is Yuri, two different things. He was not in Sputnik. Sputnik was the first satellite to leave Earth and to orbit, and then Yuri was the first guy. You can look at that smile. You know that he's excited to be going to space. So in 1957, we lost the space race, and then 4 years later, Yuri beat us to space as well. We had a lot of wonderful missions. I know that you were watching a movie when I was gone last Monday about the manned trips to the moon. It was kind of a progression, and we're going to look at this more hopefully next week. We started with Mercury. Mercury's goal was to get one person in space. Gemini, if you're familiar with the constellations, that is two. Gosh, I got to think of what it's two of. Someone in the class is going to know it right now. But Gemini, the goal was to get capsules that were large enough for two people to get into space. And then obviously you had Apollo, and that was to land on the moon. There is some new interest in the moon. NASA has kind of set its sights. We've been kind of tinkering a lot with robots on Mars, and now President Trump would like us to return to the moon. And so that's kind of back in the playing field. So it went Mercury, Gemini, Apollo. And here's some cool pictures. This is normally when kids start talking about how the moon missions were faked, and if you think that, that's fine, but I'm pretty certain that they were for real. And so that's the lunar module and some cool footprints in the moon dust. This is a neat map that shows all of the landing sites of the moon and where all the Apollo missions were. Luna, if you notice that name, Luna, that was the name of the ESA missions, the European Space Agency. They had the Luna missions. So a little bit of terminology you got to know for the moon are highlands and Maria. It looks like Maria, but it's pronounced Maria. The highlands are this whitish looking regions. And it literally is land that is higher than the surrounding Maria. And so what these mare, so mare is one, Maria is more than one, these are most likely craters that then filled up with lava. And so before we made it to the moon, Maria means sea. And so the humans down here on Earth thought they were looking at great big oceans, and they named them like Sea of Serenity and Sea of Tranquility, and they all have these super hippie names. But what they turned out to be were these huge fields of igneous rock. So we've named we've pretty much named everything. Here's your names: the Mare Tranquility, the Sea of Tranquility. So what happened, let's see if I have a picture. Nope, I don't. So when the moon was probably hit with some object, it cracked the surface and it filled that whole crater up with lava, and it just filled and filled and filled and filled and filled. And then it cooled off, forming some basalt. So the moon is covered in craters, absolutely covered in them, because unlike us, it doesn't have an atmosphere. It doesn't have any place for the meteors to burn up. Then if it's not a crater, all of this stuff that's all around everywhere, oh no, I lost it. There it is. All of this stuff, this is super fine material. If you've ever baked, like think of sticking your hand in a bucket of flour. It's really, really fine because it's all of the ejecta from those craters. So the actual surface of the moon is like a powder from all the material that has ejected that is ejected from these craters. Here's the thing I thought I had. So the formation of the Maria was this. The moon was kind of going through the same formation that we had on Earth. Every time I got hit with an asteroid, if it hit it hard enough, it would crack. It would actually crack the surface of the moon. The moon at one point probably had a gooey mantle, just like we do, and that would fill in that area. And so the mare are all filled in craters and just these big slabs of basalt and other igneous rocks. The men who went to the moon had probably the biggest disappointment of their life. When they brought moon rocks home, they realized that moon rocks were made of the exact same materials that we have here on Earth. It was all silicates and oxides and irons. There were no new materials found in the moon rocks. And so because of that, the leading formation of the moon is called the impact theory. And the impact theory is named because it involves a very large impact. So the theory goes that back when the Earth was a hot gooey ball, that we may have gotten hit by another hot gooey ball. So if you think back to the formation of the solar system, we had that phase where we had the planetesimals, and the planetesimals were zipping around that protostar, and they were either colliding and smashing one another apart, or they were colliding and sticking together. In this case, the gooey Earth and the gooey moon, neither one of them got smashed apart. Our materials kind of mixed. And so here comes this large body that smacks into the side of Earth, creating all of this material that spins and spins and spins. Our gravity was able to hang on to that material, and it eventually accreted into our moon. It makes the most sense if you think of any theory like, oh, Earth pulled in a random asteroid that just happened to be spherical. Well, that doesn't explain why we're made of the same stuff. So the exact same elements, the exact same types of rocks. There is nothing special about moon rocks other than the fact that they come from the moon. Here's a slightly more violent image. So you've got this object coming in. It looks like it shoots the side of Earth. Then you've got that material spinning around and around and around Earth, which would explain why the moon had molten insides that could then fill in the mare. This is called the impact theory. That is what I shortened your notes to for moon properties. I really pared it down to the bare minimum. In the back of the class, there is in fact cookies. Whenever I see these cookies at Fry's, I always think of the moon. And so if you want to ask the sub to pause this video for a minute and go help yourself. I think there should be enough for everyone to have 2 cookies. If there's anyone who doesn't want 2 cookies, well, let someone know so they can eat your cookies. Cookie break. All right, I just took a break myself. Hopefully you're able to get to cookies. Please look around, make sure there's not a mess. I don't want any sort of crumbs or creamy goodness to be found on my floor, just kind of lying around there. That's no fun. And now turn your notes to the next page for phases of the moon. I'm going through this material kind of fast, guys, because A, we're running out of time, and B, you covered this way back in 7th grade. So I know that was a very hard time for some of you to remember because middle school is kind of traumatizing, but do your best, because some of these terms that you see for moon phases should look familiar. So you are on the second to last page of your notes, phases of the moon. Phases of the moon. This is going to be a tough concept for me to teach without me being there, because I always use a lot of cool visuals that will help. And so if we have any misunderstandings after watching this video, I'll be sure to clarify anything that you need tomorrow when I'm there. You guys are such troopers for putting up with this. So the lunar phases are caused by the fact that the moon rotates the Earth. So something I always stress to kids is that half of the moon is always lit, and not, there we go, always lit. This is the big deal. If you walk out of here not remembering anything else today, please remember this, that half of the moon is always lit. What changes is that portion that we see. What part of the lit side of the moon are we going to see? So here's just a cool composite picture showing that even though the moon might look one way, like over here you can just see the crescent, half of it's still lit. We just can't see the other portion of it. In the case of a full moon, we're seeing the entire half that is lit. And so as the moon orbits around the Earth, we just get a different view of that half-lit portion. And so we're going to start looking at diagrams like this. Just kind of soak this in for a minute. Whenever you see a diagram, you always want to ask yourself, where's the sun? Where's the sun at? Because that's going to really determine your ability to get questions like this right as we start looking at different examples of moon locations and eclipses and things. So the sun's up at the top. Here's Earth. So I'm using a mouse to draw, so this might look absolutely awful. Ooh, that almost worked. So as the moon goes around us, this takes 28 days. So it takes 28 days for the moon to go around Earth one time. Notice how in every single position, no matter where the moon is at, half of it's always lit. This dotted line represents what we would see standing on Earth. So look at the new moon, for example. This is where our lunar cycle starts. In those 28 days, here is day 1. If I'm standing on Earth and I'm looking out, I'm not seeing any of the lit side. Put yourself on Earth and look out at that way. Here's your dotted line. Okay, so I'm seeing the entire, what's called the dark side of the moon. Now go by 7 days and we're a quarter of the way around our rotation here. Ooh, now when I look at the moon, it's lit on the right and it's dark on the left. So this is a perspective thing. Stand on Earth and look out. Go another 7 days and ooh, look, oh my God, it's a full moon. Now I'm seeing the entire side of the moon that is lit. And so we're going to practice learning at where in this location will the moon be to look different ways. So here it is in order. So like I said, it takes 4 weeks to go through the whole lunar cycle. I think that's a blank on your paper, so look for that. It takes 4 weeks to go through the lunar cycle. We start with seeing the new moon. Halfway through, we're going to get to the quarter moon because we're seeing half of a half. If you're sketchy with math, half of a half is a quarter. It's going to continue getting brighter, full moon, and then it's going to appear to start to get darker. Remember, it's not actually getting darker. We're just seeing different variations of that half-lit portion. Here's some terms you've got to fill in. Waxing and waning. This is always a good wax on, wax off time. Waxing is when the moon appears to be getting brighter. This is the first 14 days. It is waxing. And then it reaches full moon, whoa, and then it wanes. Wanes means it appears, wane is when it appears to get less bright, or wane literally means shrinking. Oh, sorry, that was kind of fast. To get growing, waxes, shrinking. Other terms you have to know are quarter, crescent, and gibbous. A quarter is when half of the moon appears to be lit. Remember, half of a half is a quarter. A crescent is when we see less than half lit, and a gibbous is the weird word that we call it when we see more than half lit. All right, so now you can recognize these words. Waxing, it's getting brighter. Waxing, waxing. Whoa! It's not going to get brighter than full moon. And then it wanes, 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 wanes until it gets darker. So it gets darker and darker and darker. So we're going to fill out this little baseball analogy. This was written by an earth science teacher who used to work here. Her name is Miss Allred. She's currently the online teacher for earth science. It's a little bit cheesy, but we're going to follow along and do it together, and make sure you draw it right, because this is going to be important, an important study guide for you as we move forward. So we're going to do the steps together. Step 1 says the earth is at the pitcher's position. So if you're unfamiliar with baseball, well, the pitcher goes there. So draw a little earth on your diagram and your notes. Doesn't have to be pretty. Step 2 says the sun is at the catcher's position. All right. Oh, sorry, oh man, I got to zoom out a little bit. So my sun is right there. Sorry. There's the sun. The next step says when a batter is coming up to bat, they are new, just like the new moon. I warned you it was cheesy. So here's home plate. You got a new batter. Color in that whole circle. So we are representing what we would be seeing on Earth, because obviously we're not representing what the moon looks like, because the moon is always half lit. We are going to put in these circles what we would see from Earth. The next step says after they hit the ball, they run to first base. So we're going to skip the crescents and the gibbuses. We're going to do the easy ones. So we're going to draw first quarter. So what we would see on Earth would be light on the right and dark on the left, and we're going to label that first quarter. This is also has been called waxing quarter. You might see that on a worksheet that I think today's worksheet has waxing quarter. So if you want to put that in parentheses, waxing quarter. The next step says, if they hit a double, they're really full of themselves. Draw full moon at second base. So now we're going to go to second base, and we don't have to draw anything. We're just going to label it full moon. The next step says at third base, they're at the last base before home, or last quarter. So now we're going to draw the other one. Notice how it's opposite. The dark is on the right because you're waning, and the light is on the left. Oh, there's my parentheses. I knew I had them in here somewhere. So we did all the easy ones. New moon is where it starts. If I was on Earth, I'd see no light. 7 days later, first quarter. 7 days later, full moon. 7 days later, third quarter. 7 days later, we're back to the beginning. All right, so now what I want to do is have you add the arrows to your picture, showing the direction in which we're going. So it's obviously going counterclockwise around the Earth in this case, from our perspective. And you're gonna, this can be waxing something. These are both waxing. We got to figure out they're gonna be crescents or gibbous or gibbi, and then these are waning over here. All right, so let's say, now notice how the sun has moved. In our example, the sun is down here. Because remember, you got to ask yourself, where's the sun? In this example that we started with, the sun's up here. So I'm going to look at the same position. If this is new moon, because new moon's always going to be between the Earth and the sun. If we're going to this one, look at your dotted line. If you're standing on Earth looking out, you would have a little sliver of light on the right. So this is going to be called a waxing crescent. So it's a crescent whenever it's less, it appears to be less than half lit. So new moon, waxing crescent, first quarter. Now it's going to continue to wax. It's going to continue to get brighter, and that's going to be called a waxing gibbous. New moon, waxing crescent, first quarter, waxing gibbous, full moon. So now, after full moon, remember it's going to start to wane. So it's going to appear to start getting darker, and the dark is going to come from the right-hand side. So that was horribly drawn. Wow, I must have done that on a laptop or something. After full moon, you're going to go to waning gibbous, then your third quarter, then your waning crescent, and then now you're back to new moon. And we're going to have loads of practice with this. So if this is not coming back to you from your 7th grade science, don't worry, I got you. It'll be fine. New moon, waxing crescent, first quarter, waxing gibbous, full moon, and then it's going to wane all the way back to new moon. Make sure you're labeling correctly. A lot of students in the past, they end up using this kind of as their study guide and their reference sheet for a few assignments and examples, and they label the thing wrong. So they're looking at wrong answers all week. So don't be that person. Make sure your waxing goes new moon waxing and then full moon waning. And this is what your final product should look like. Double check that you have everything. Okay, once you feel like your diagrams are good, could the substitute, could you please hand out the worksheet that I left on my desk to the kids? And then guys, if you could write your name on that, you're going to do a couple practice questions before you go today. Okay, once you have that worksheet, I'm going to show you how to do the first one. So what you're going to be doing is you have these different scenarios and you have to look at, remember, where's the sun? It might help you to turn that picture we just drew so it's oriented the same way. So for example, the sun is at the bottom of that chart we made, that baseball diamond thing. If you turn your paper 90 degrees clockwise, that would orient the sun on the left, and maybe that will help you figure out these answers. So what you want to think to yourself is, if you were standing on the earth, what would you be seeing? Feel free to draw all over this thing. So in this example, obviously, here's the light part. This would be the, let me pick a more logical color. This would be the dark side of the moon that we're seeing. So what you're going to do on the line is you're going to write the name, which would be new moon, and then you would draw what we would be seeing on Earth, which would be a big black dot. And so on that front side, you're going to look at each one of these scenarios and you're going to figure out what phase of the moon would we be seeing here on Earth. This is really easy, by the way. Flip it over to the other side, you have a few more questions. The first one asks you basically just to label these. So if you're having troubles figuring it out, this is the sun over here. The sun's to your right. And so you're just going to label the letters that are there. And I think there's 2 more questions at the bottom for you to draw. It says, like, put the sun in one spot, put the earth in the other. And so you're doing the same thing. This needs to be done when you walk in the door tomorrow. We're going to go over them. You'll be able to ask me questions. I know it's hard to learn new things when I'm not there, but you'll be able to go over that with me. Don't forget, tomorrow your keynote is due at 7:30 a.m. This is a coupon exempt assignment. There are no more coupons. If you turn it in, if you turn it in late, it's going to be half credit no matter what. And so please, 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 please do what you need to do to get that done and submitted on Canvas. Remember, if you have animations in yours, submit a keynote. If you do not have animations in yours, submit a PDF. So that is up to you in which your format you're going to turn in. But if you spent time doing drawings or animations or cool magic moves or whatever you have in there, I want to be able to see them. And so please turn in the keynote file, not a PDF. Feel free to email me any questions that you have, or swing by my classroom later today. Like I said, I should be here after 5th period, and we will have a smooth rest of our week. Thanks, guys. Have an awesome day.